Okay, the first question we wanted to address in class today was the domain of f of x equals 1 over x squared. However, that requires that you know when we start what the table and the graph of that function are. Something was to be mastered 2 weeks ago. And nobody really could do that quickly. Nobody really had that in their head. So we didn't talk about it. Couldn't make a table. Yeah, I didn't have the table in your head, didn't have the graph in your head, didn't know the table and graph well enough to do that table and graph in 1 minute, which is the standard for the 5 functions we gave you. So please understand the necessity of doing that, because everything that we're talking about today is to be based on the assumption that you understand those graphs. Okay, and people simply didn't. So make sure you get that down by the first of next week at the very latest. Get it down as quickly as possible, and the way to do that is to keep making the tables, drawing the graphs. Make the tables, draw the graphs. All 5 functions, do it at least once every day until it takes you only 5 minutes to do all 5. Okay, so we then proceeded, I didn't make any more comment on this, but we look at f of x equals 1 over 2x plus 9. The question as phrased was, what x values can't we put into this function and get a result? And the answer in this case is any x that doesn't make this 0, because division by 0 is undefined. So we don't get a result if the denominator is 0. Well, so we reason this out. Okay, denominator, there's a denominator. The denominator can't be 0. So what do we conclude? We find the value, we conclude that 2x plus 9 can't be 0. Okay? So we find when it is 0, so we know to exclude those values. So 2x plus 9 is 0, we solve, and I mentioned I do want you to be able to solve this in detail. It's not we move 9 over here and change its sign and then we put a 2 under it. It's we subtract the same thing from both sides to get this, which does have the effect of moving this 9 over here and changing its sign, but there's a rule for it, and it's essential to know these rules so we don't get them confused later when we have more complex expressions. Then we multiply both sides by 1/2, which is equivalent to dividing both sides by 2, which is also a legal way to do it. I usually choose to multiply rather than divide, because when you're dealing with fractions, you would multiply by the reciprocal of the fraction. Dividing by a fraction by a fraction gives you a complex fraction that then has to be simplified in a couple of steps. So I like the idea of multiplication here because it works generally as well as, or in many cases better than, division. Okay? In this case, either would be okay though. Multiply by 1/2, divide by 2. Either way, you're going to get x equals negative 9 over 2. Okay? Now when you're doing this quickly, you're not going to want to write all that out. You know, you got 17 problems to do. You're going to do it by habit and visually, but don't do anything by habit and visually that you can't relate easily and quickly back to the rules. Okay? And these are the rules. You should be able to write it out like this, if necessary and if requested. And if you want to remind yourself of what rules you're following when you start moving things around. Okay, well, we conclude that this denominator is 0 if x is negative 9/2. So in evaluating the function, x can't be negative 9/2, which means that the domain includes, there's no other number that gives you trouble, okay? The domain of the function will then be all numbers except negative 9/2. Now there are 2 ways to write that down, the interval notation, everything from negative infinity up to negative 9/2, and everything from negative 9/2 to infinity. not including 9/2, so we have the parenthesis as opposed to the bracket. And of course we can draw a picture of this. It's all numbers on the number line except negative 9/2. So we label negative 9/2 and we put an open circle around it. And we see the two intervals. Here's the interval from negative infinity up to negative 9/2, this one. And the interval from 9/2 to infinity, not including 9/2, and that's this interval. Okay, we looked at another example. And originally I just had 1 over x squared minus 4 to emphasize it, but now we look at x squared over x squared plus 7 over x squared minus 4. It doesn't matter. It doesn't really matter what the numerator is. Look at some. Well, as far as finding the domain, it doesn't matter what the numerator is. The numerator can be any value. There's no problem dividing any number by any non-zero number, okay? But the denominator can't be 0, so x squared minus 4 can't be 0. So we solved to see when x is 0. Now, and everybody solved it and got 2, okay? Because it's very easy to rearrange this. There's the step we take. We can very clearly see from this we're going to get x squared equals 4. So everybody said, okay, x is the square root of 4. That's 2. Well, that's good, but it's not quite right. Okay, 2 is fine. 2 is a solution, but there's another one, and nobody seemed to be able to tell me what that was. So we chose to emphasize the fact that, well, x could be negative 2. If you square negative 2, you get the same thing you do if you square 2. So if x is negative 2, clearly x squared minus 4 is going to be 0. And the lesson there is that if you have x squared equal to a number, the solution is x equals plus or minus the square root of that number. Okay? Because whatever the square root of that number is, if its square is equal to what you want to find, then the square of its negative is also equal. Okay? Now there's another way to get this, and this just came up because somebody said, well, there's a difference of 2 squares. That was very good. We want to recognize these things. So having had that comment, I went ahead and solved the same equation by factoring. Okay? X squared minus 4 equals 0. Factors into x minus 2 times x plus 2 equals 0. And if you don't know why that is, you'll need to. So it might not be a bad time to review some of those special formulas and the whole idea of factoring, but we will be addressing it, especially in the MCR here, because I know that that's still going to be an issue for people. Okay, so now the product of 2 numbers is 0. The only way you can multiply 2 numbers and get 0 is if at least one of those numbers is 0. You can't multiply 2 non-zero numbers and get 0. So one of these numbers has to be 0. So x minus 2 has to be 0, or x plus 2 has to be 0. And then the solutions to this, x minus 2 equals 0, solution to x equals 2. X plus 2 equals 0, the solution is x equals negative 2. Well, those are the same solutions we got up here, and actually this is why this is so. But of course, this is so, you can directly reason out why it's so also. Okay, so what's our domain? Well, it's going to be, the only numbers that give us trouble are 2 and negative 2. That's going to give us a 0 in the denominator. So we could sketch it, okay? Any real number except negative 2 and 2. And the intervals go from negative infinity up to negative 2. That's the interval negative infinity. The open interval negative infinity, negative 2. It's an open interval because we're not including negative 2, and we use a parenthesis here. And then from negative 2 to 2, again, an open interval, an interval that doesn't include the endpoints, doesn't include negative 2 or 2. So that's going to be written this way. And then the open interval from 2 to infinity. So there's the domain of this function. Now, we could talk about the range. We did talk about the fact that x squared plus 7 What can you tell me about the values of x squared plus 7? Well, we went back to, okay, what can you tell me about the values of x squared? What can you tell me about the graph of x squared? Okay, well, the graph of x squared, everybody knows, it's the first thing we looked at, and it's a parabola with a vertex at the origin. Meaning that all the values, and people picked up on this kind of quickly, and then see, it's one benefit of understanding these graphs and having them in your head and having them there without having to refigure them. No, they're just a benefit of understanding what you are seeing. So people picked up on this and told me that, well, any x value above 0, well, that actually includes 0, so it's any x value that isn't negative, but it's the interval from 0 to infinity, and it's a closed interval, a half-closed interval. It includes 0, so it would be the interval bracket 0, comma, infinity. Of course, you always have an open interval or a parenthesis on the infinity because it's not a number. You never can get there. So x squared is anything, can take any value from 0 to infinity. So x squared plus 7 can take what values? Well, somebody said it, and this is good. Said, well, 7 and up. Okay? If you're adding 7 to the set of numbers from 0 to infinity, you get the set of numbers from 7 to infinity. And that's going to be instrumental in figuring out what the range of this thing is. Now, we didn't go to the range because we didn't understand the basic functions well enough to build on them. So that's going to be different next time we meet.